In part 1 we learnt how to animate a variety of boat shapes on the Houdini procedural ocean. We sampled the ocean surface and got the boat to move rigidly across it in a directable way. In part 2 we will introduce roll and pitch to give the feel of a real boat reacting to real water. We will achieve this by making an intermediate rig that is connected to the water and controls the boat using virtual springs, going from this to this to this to this. Now, last time we got the boat to stick to the water, which is great, but it's a little mechanical, a little bit rigid perhaps. Today we're going to give it some roll and some pitch. First thing we're going to do though is we're going to link our camera to the boat so that we can be zoomed in more, and the camera will move with the boat, and that way we can see what's going on with more precision. So we're going to use the point command, and I'm going to make a null first and link the camera to that. So the camera is now the child of this null, and we're going to control the position of the null using a point command. So the thing we want to attach it to is in boat types, and it's here. This is our controlling point, so that's the point that we use, and we're going to use that to control the camera as well now. So I'm just going to pull a null off there. And I'm going to go Control C. Go back up here. Now the point command works like this. You go point, and then you put in inverted commas the Houdini node that you wish to take the point information, the attribute from. So I'll put that in there, Control V. So that's the object we just copied, and this is the point number. So there's only one point in this case, so it's 0, because it's coding stuff. The first thing is always 0 in coding stuff. Next, in inverted commas again, is the attribute that we wish to pull out of that object, and because that attribute is a vector, which component of that vector we're getting. So that's that'll be 0, 1 and 2, because there are 3 components to that vector. So I'll copy that down, do that here, and then I'll just, no, I won't, I'm going to do that. I'm going to Control C, and that goes into the translate for the null. Control V. You should see the null move. Here we go. So the camera's slaved to the null, so the camera moved as well. That's good. And then the Y will be 1 there. Control C. V. Z will be 2. Control C, Control V. Good. So now the camera is a child of that null. That null is fixed to the ship, and so I can do what I like with the camera still, because it's a child. So I can still, oops. Camera lock on. I can zoom in nicely like that. Where's the boat not showing? The boat's not showing because it's there. Now our camera will follow the boat nicely and we can assess our motion. So it's a little bit mechanical. It sticks exactly to the sea. It's a bit mechanical. So let's fix that. Right, first things first. Sometimes when you're playing back the animation, you might find the sea has kind of locked up. This happens, I don't know why, but all you've got to do to unlock it is just go up to the sea object, click around a bit, and that kind of shocks it into action, and it works again. What we need is an object with 4 points in it, 2 points to control the roll and 2 points to control the pitch of the boat. So we want a curve, and we go to the top view and zoom in a bit. Make sure the grid snap is on. One, two, three, four, and close. Now we want to match that to the exact size of the shape that we use to pull the information out of the ocean surface. So that's that shape. So we use a match size, and we're going to tick the box for scale to fit and tick the box off for uniform scale, so it fills the entire shape. And then this plugs into the copy to points where the boat shape, hull shape was before, which gives us this lozenge shaped thing that animates in the same way the other one did. There we go. So we need to connect springs to all these points. We're going to use a chop net. So first thing we need is a null. And then that null, we'll just rename that. If you rename it in capitals, then it comes up at the top of the list. Yeah. Chop net. Dive inside. And on the geometry node. And we're going to pick that null. There we go. Positions okay for now. We want animated. Positions okay. TY, TY, TX, TY, TZ. And we'll attach another null to that. And call that chops out. The springs will go in here. You can put anything you like in there. So now we connect a channel box which talks to that, and we want to pick that null that we created inside the chop net. Chops out, there we go. and animated again. Now, when you're using chops, you quite often find that the machine will pause while it kind of has to pre-bake the channel. So don't worry, it's not hanging. There's no change as yet, but that's all linked up and working. Now we can put our spring in, and that has 3 parameters to play with. The spring constant is the overall stiffness of the spring, so if you put that to a high number, it will just look like there's no springiness at all. Mass, and mass is like the inverse of the spring constant, so the higher you make that, the more sluggish and laggy it will be. And the damping constant prevents large oscillations from building up. So it's, in this case, I guess it would be analogous to the viscosity of the water. Now if we go to here, we highlight, we template the non-moving, the non-sprung one, and play it back, you'll see that it twangs around because it's on springs. But it twangs around in all 3 dimensions, so X, Y and Z, and really we just want it to oscillate in the Y direction. We don't want to lose our positional correlation kind of thing, forwards and backwards and direction. So we need to sort that out. So what we're going to do is drop in a point wrangle and we're going to get another attribute up and just do the springs. So we're going to get another attribute up, copy Y position into that attribute, do the springiness thing just on that attribute, and then copy that attribute back onto the Y position. So we call it Y pos. So F for float at Y pos equals at P dot Y. Semicolon. Right, now so we'll change geometry accordingly. So instead of P we want Y pos, and we just need TY out of those 3 because Y pos is a float, not a vector. Do the same thing in the channel box. That's showing an error now because it doesn't have P anymore in the chop net. TY Y pos, error's gone. And now we should just get oscillation in the Y direction, up and down, not all 3. Oh no, we missed something. We've got to copy the Y pos attribute back to P.Y. So point wrangle, and then at P.Y equals at Y pos. And there we go. So in this case the outline one is the sprung version. Now we can hook up the boat shape to that as we did before. So we need an extract transform. which gives us a dot with position and orientation. And then we want a copy to points, and we'll wire that in with the original boat hull shape. Oops. No, wrong. And there we go. So that's the sprung version of the hull. So one more thing left to do, and that is we need different springs for forward and backwards and side to side, or pitch and roll. So if we make a group and pick the front and the back points of our little lozenge shape, points we want to select and get the numbers up. So it's 0 and 2. We want 2, and that's group, we call that pitch. Points, we call that pitch points. Now we'll dive back inside the chop net, and we'll make 2 versions of this. One called pitch, one called roll. That one has the group pitch points, and this one will have the group exclamation point pitch points, or exclamation mark if you're English, and that just means everything that's not inside pitch points. And we merge those two together. Check it's all working. It's just pre-baking the channel again. So that doesn't look much different because both the springs are the same, but I can show it works. If we dive into there, put the damping a bit up on the pitch, and then I'm going to take the damping completely off on the roll, just to show you that it works. There we go. Now we'll put it back to something a bit more sensible. And that's it for this part. Next time I think we'll do the effects of wind, so that's more for the sailing craft really, but it's an important thing. So yeah, we'll work out how the wind affects it.